Okay. I will tell you that the quizzes are graded. I know a lot of you aren't done, so I will not put what you have in the grade book until Friday.
Why? I really want to see what I got.
Yeah, you put the.
I got a really bad school.
Yeah, why would you put them in a zero?
I don't have them in a zero right now. There's nothing.
Wait, can you put
I didn't like some of
I mean,
it.
it's a blank. It's a blank.
Can we come and ask you
Can we
What?
come find out? Yeah,
Why?
Yeah, it's in my office, so.
Can you
Thank you.
cook food? Can you
It's always good.
I just
It was funny. This is great. I have all really. That's true.
What do I do?
I don't know.
Never mind.
All right.
I just got it.
Dude, it's fun.
All right. I saw that some of you did the capstone review over the weekend. Awesome.
Wait, you're kidding. There's another capstone?
Huh?
There's another capstone?
Yeah, there's 3.
Yes.
You're doing great on it. So, all right. Too many this time. So, if you need to finish up your test, which is already graded, just come in on an off period. Doesn't matter if I'm teaching or not, or before school. Tuesday, Thursday, I do have meetings. All the rest of the days don't. I should be available pretty much each day after school. Just text me if you're coming after school to make sure I'm still here, if you don't mind. So, as far as the people who got done with the quiz, they did quite well. Unfortunately, some of those you didn't get done, there's like some of you didn't get like 3 or 4 problems done. So then all of a sudden you're missing like 12 to 15 points, which it's not in the grade book yet. I won't put it in the grade book until Friday. So I just want to give you guys a little leeway on that. If you want to see what you got, I will have that. So come see me. I don't have it with me, so don't ask me right now.
I bet someone's gonna ask right now.
Hey,
I
can
know.
I see it right now?
Yep.
Can I come an A?
Sure. All right. So does that sound fair? I don't have that updated, so don't look at that board because that was still last week. So weird. Like we're coming down pretty quick to the end, huh?
30 days.
How much?
30.
Holy cow! Really?
That's what my science teacher said.
Dude,
He's not a math teacher, so you can't really trust me.
that's true.
Carl's erratic.
Carl is erratic.
They can apply. All right. So we didn't have. If you have any old homework, make sure your name's on it and just bring it up. Put it up here in this folder. And ready. I'm starting to teach in 5, 4, 3, 2, 1.5, 1.25, 1.8, 1.16, 1. 0. Okay. So reciprocal functions. Reciprocal functions. So let's try and remember. How do we know a reciprocal? Means that I basically flipped it over. Okay. Oh, I'm sorry. So we have to look at the first reciprocal function is function at x is equal to a over x. That would be, some sort of thing. What restriction will we have on the domain if we looked at this? So what could x not be equal to? 0. Yeah, it can't be equal to 0. So if you wrote the domain in our fancy way, it'd be negative infinity to 0, 0 to infinity. And that would tell you that we are not including 0 as the denominator. So there's restriction. Now, I'm going to tell you that we're going to get into, we already have dealt with vertical asymptotes. There's also horizontal asymptotes. And just for those of you who like things that comes in threes, there's also something called end behavior asymptotes. Sometimes they're called slant asymptotes. And they all exist. And the nice thing is the vertical asymptotes are quick and easy to find because you just figure out where the domain or the denominator would be equal to 0. That would be your vertical asymptotes. The horizontal asymptotes, there are 3 rules that go with it, and they're pretty simple. And then the slant / end behavior asymptotes are something where we use either synthetic or long division to find out what line they go along with. So, what effect would this restriction have on the graph? Basically, if I were to graph something, these start looking something like this. That's kind of what these graphs start looking like. Okay, so there's 2 parts to it because you have an asymptote in the middle. And let's just see what this brings us. And then, can the graph have X-intercepts? I would say possibly. Can it have a Y-intercept? I would also say that's a possible answer. Remember, a Y-intercept is where you would plug 0 in for X, and you would figure out what that is. An X-intercept would mean I plug 0 in for Y and find that. And of course, when we dealt with bounces and wiggles and crosses, those all exist as zeros for X-intercepts. Y-intercept is usually only happens once. Yes, there are relations or graphs that we can look at that cross it twice, but if it crosses it twice, that relation is not a function. Okay, so let's go simple on this. So the vertical asymptote is the one that we have to realize is X can't equal 0. So right here is my vertical asymptote. We can't cross that. That's like the barrier. And then if we wanted to start looking at the horizontal asymptote, we do indeed have this, and the horizontal asymptote works this way. One of the rules is if the degree on top is less than the degree on bottom, if I could spell, then, so there's a comma right there, then you have y is equal to 0. So then we have a horizontal asymptote that looks like this. And now you're looking at it going, well, how do I know the degree on top? Well, if there's not a letter on top, that means I technically would have had x raised to the 0 power. So this would exist here. Okay, no, you can't do a tug of war because you still get the bottom winning. So the degree on top is less than the degree on bottom, so y equals 0. So you have those 2 asymptotes that take place, so we can't cross over those in this case. Do I have an X-intercept or any roots? Well, if I plug 0 in for my X value, I wind up with 1 over 0, which that's undefined. Okay, so will it cross the X-axis? In this case, no. And then Y-intercepts, that means I'm going to plug in 0 for X. And what happens if I plug 0 in for X? It becomes, well, the X-intercept, you plug 0 in for the opposite. So that's also undefined. So in this case, we don't have any X or Y-intercepts. Okay? So how do I even possibly approach graphing this? Well, I would say let's make ourselves a t-table. We want -2, -1, 0, 1, and 2. Can I have a negative in the denominator? Yeah. So 1 over -2 is 1 over -2 is just -half. Okay, so if I want -2 half, I get to like right here. And then if I plug -1 in, I get 1 over -1. 1 over -1 is -1, so I get -1, -1. I can't plug the 0 in. This doesn't work. So this is what this graph is going to look like. That one. And then if I plug 1 in, 1 over 1 is 1. So I get 1 over 1. Yeah, you know, it's always good when I start Monday and I teach things correctly. I'm teaching it correctly, it's just I'm not able to put my dots in appropriate. Okay, so -2, -1/2 is down here. I'm so sorry. That gave me a -1. So that's going to look like this down here. I'm sorry, I made that wrong. Then if I plug the 0 in, that won't work because I get a denominator of 0. 1/1 is 1. And then 2/1 is 1/2. So that's what this graph looks like. Okay, it's called a hyperbola. And a hyperbola is actually one of the conic sections. And let me just define for you way over here, just so we kind of have an understanding. Conic sections work this way. You have a point in the middle. You have a line this way, line this way. And let's say I can draw myself a nice circle here, a nice circle here. Can everybody see that I have two cones that are meeting each other at the, okay? So the conic sections work like this. If I made a line that's perpendicular to the center line, that's just one cross section. This creates a circle. If I have a line that cuts it like this, that is not parallel to any of the black lines. This creates an ellipse. Remember, an ellipse kind of looks like this. It's a circle kind of pulled out. And then we have this one. If I kind of, let's see if I cut, I don't want to cut it. I want to cut, if I cut like this, and that blue line is parallel to one of the black lines, that creates a parabola. And you guys know what a circle is, and you know what a parabola is. Okay? And then the last one is, if I make a cut that is parallel to the midline, like this, that makes an ellipse, or a hyperbola. Hyperbola. And a hyperbola does this and does this. Notice the hyperbola looks kind of like a parabola, but there's two of them going opposite directions. So that's how the conic sections are derived, developed. That cone-shaped thing is called the nape, N-A-P-P-E. You don't need to know that, but it's just, these are all the things. And then if you really want to twist life around in a way that you might not be comfortable with, when you did geometry last year, some of you are doing it this year as well because you're doubling up, you're doing everything that's on a XY axis or a Cartesian plane. You start doing geometry on conics. There's one rule in geometry that everyone feels real comfortable with. And you're in geometry, all parallel lines don't intersect. Whereas if you do geometry on on the conic sections, all parallel lines intersect. So it's a much different thought process. Because what they do is they actually should go through this. They all go through the center. That's kind of the definition of the parallel lines in this kind of world. It's a weird math. It's something that you won't see in high school, so don't panic going, we got to know that. No.
It's kind of like a wormhole. Like that's what
It is a little bit. A lot of that kind of stuff does indeed go along with it. So, what we created a hyperbola has asymptotes. So when you start drawing hyperbolas, you're creating it on the Cartesian plane, so the XY axis. So you often have vertical and horizontal asymptotes. The domain and range have values that don't work. And then you have two symmetrical parts called branches. Okay? So we're going to be kind of working with the hyperbolas on this, which are part of the conic sections, though we're not dealing with the conics right now. So this next problem, vertical asymptote. Well, yeah, x can't equal 0. So my vertical asymptote's here. The horizontal asymptote, y can't equal 0. So we also have this. And then what would that 3 do when we plug values in? So we have no and no on both of those. And again, if I did my table, x, y, -2, -1, 0, 1, and 2, well, we can cross 0 out because it won't work because we divide by 0. So if I plug 2 in, I get -1.5. So -2, -1.5 is like here. If I plug -1 in, I get, excuse me, -3. It's -1, -3. So this is what this one looks like. And then it's going to match on the other side. If we plug values in, I get a 3. So 1, 3, and 1.5. So there's your hyperbolas. What did the 3 really do? It created something called a vertical stretch. It's sometimes hard to see the vertical stretch. But if we went between this and our previous graph, we would see that it's stretched by a factor of 3 in the vertical direction. And then we have the one where we have a negative in there. So we still have this and this is our vertical and horizontal. And then still no's on both of those answers. If I made my graph, 0 doesn't exist still. If I plug -2 in, I get +1, so I get -2, +1. If I plug 1 in, I get 2. And then if I plug 1 in, I'm going to get -2. If I plug 2 in, I get -1. So, does everyone agree that the difference between this and this is they flip-flop each other because of that negative? I mean, that's the difference between the two.
The lines on the graphs kind of look like logarithm things.
They do look similar to logarithms, absolutely. Although a logarithm doesn't have a horizontal asymptote as it says that we dealt with, though they can exist if we get really demented. Like meaning if you had like log of x squared plus 5x over log of x plus 2, something like that. But we didn't have to worry about those.
That's good.
All right, so summarize. What effects does the value of A have on the graph? If it's a negative A, it kind of does something called a symmetry about the origin. So it flip-flops the regions you're in, and you just have these asymptotes. So the A value allows it to grow faster, and that's about all we're worried about there. Is there anything that we need to... Okay, so now if we consider this function, what value would allow the denominator to be equal to 0?
4.
Yeah, so in this case, x cannot equal 4. Okay? So that changes our vertical asymptote. The horizontal asymptote in this case, because the degree on top is less than the degree on bottom, we still have y equals 0. Gents, you guys are chatting over there way too much, and it's a brand new concept. Okay, so there's just a few things to consider. I think we'll probably graph this. Let's see. We have a vertical asymptote at x equals h. So if we are adding or subtracting to the bottom, the graphs are hyperbolas. We have a horizontal asymptote. That k value will move that horizontal up and down. So if we're adding something to it, the domain is restricted to -infinity to h and h to infinity. We don't know what h is, whether we're adding or subtracting it. Remember, it's always opposite if it's adding or subtracting to a letter. If it's adding or subtracting to the whole thing, that changes what the range is. Okay, so let's see if we can apply these rules think we have a graph coming up. Oh. All right, let's see. I got that. Okay. Sounds good. All right. We're just going to move on. All right. So, item 1. The denominator can't be equal to what? 4? Okay. So that's my vertical asymptote. My horizontal asymptote. Do I have a k value out there at all? No. So it's still this. Okay. So x is not y is not equal to 0. Is there any roots? Will this cross the x-axis? No. Will it cross the y-axis? Well, this graph is going to look like this. This graph, it's a negative. So what did our negative on the A do? The negative made it there and there. So I made it like this and like this. Agree? So what, if I plug 0 in for x, what do I get out? I get half, positive half. So positive half is right there. So that's the point 0, half. So does it cross the y-axis? Yes, in this case, because we shifted our asymptote to the right. Okay, vertical asymptote, x can't equal 3. What's my k value? 2. So y can't equal 2. Looks like that. Do we have any roots? Is it possible that it'll cross the x-axis? Well, yeah, this graph, it's not a negative in the numerator, so this graph's going to look like this. And it's going to look like this. So can we find where it crosses the x-axis? So the math that's taking place here is I'm going to go something comma 0. So that means with the math, it's going to be this. We're going to go 0 equals this, which means I got 0. I'm going to subtract 2, so it's minus 2 equals 1 over x minus 3. Bring the x minus 3 over. Distribute, so I get negative 2x plus 6 equals 1. Subtract the 6, negative 5. Come on, 5. And that gives me x equals 5 over 2. 5 over 2 is 2.5. 2.5 comma 0. And then any y-intercepts. So I'm going to plug 0 in here. If I plug 0 in for that, I get y equals 1 over negative 3 plus 2, which is equal to 2 minus a third is 1 2/3. So 1 2/3. So 1 2/3. So again, because we shifted up by adding the 2, that allows us to have it cross the x-axis. Being that we shifted it right 3, that means that it would cross the y-axis as well. Questions so far on this? How many pages do I got left? 2 more? Cool, that works. It's just one more slide, 2 problems, right? All right, so rewrite the function so that y equals a single rational expression. rewrite the functions. Rewrite the function so that y equals this. Oh, okay. So on the left, we know that y is equal to 1 over x minus 5, yes? On the right, we also know that y is also equal to 3 over x minus 2 plus 4. I think what they're looking for is this. Is that okay? I think we could probably leave it like that for right now. I imagine at some point we'll have to solve it, but as of right now, that's where we're at. Okay, good. Kind of a shorter little Jim Dandy. What does this look like? This was 11F. 11F. That. What do you say we do 11F odds? And if you give me a good try on that, we'll make sure we hit those tomorrow. But they should go along really nicely with the notes today. So, a few things, just future. So think about if you need to finish the test or if you have to take the test, let's try and get it done by Friday. I mean, if you had a swamped week, I get it. But let's see. Cooper has this blue one. Landon, Kyle, Grant's not here. Peyton, Cooper, you have another one to make up with me. Grant has another one to make up with me. And then Olivia, you have the calculator. Thing's pretty quick. So does Hannah. And anybody else have anything else? Logan, you have the quiz 9 F through K to do. Peyton, you have quiz 9 F through K. Olivia, you have 9 F through K.
Yeah.
So not trying to add too much to your plates. Maybe we try and focus on those. I mean, think of it this way. If some of you have quizzes that are from too far back where it's like you don't know how well you'll do on it, I promise you will do better than 0 points.
That's right.
Good? Everyone have a good weekend?
Yeah.
Yeah.
So yesterday, I know some of you probably see this regular, but in my neighborhood we don't see a whole lot of wildlife other than raccoons, coyotes, foxes, and of course different types of birds. But yesterday we're eating Sunday dinner and I could see out of the front of the house and we had 2 turkeys come walking down our street.
Really?
Yeah.
That's awesome.
It's like, dude, dinner.
Make the mashed potatoes.
Yeah,
and
run them over. No, I didn't run them over. We ran out front and watched them for a little bit. I can't. We're too close to houses to shoot anybody. I got too many neighbors that are too sensitive that if I shoot them, they'll call the cops.
Mr. Sturb, one time my brother killed 2 hogs with 1 bullet.
That's awesome. That's a good shot.
Yeah.
It is turkey season.
That's Texas stuff right there.
Some of those wild boars they got in Texas, I heard some of those things get pretty monstrous.
Yeah, it was